In this video, you will learn how to solve equations with exponents. So example 1, we have h squared equals 36. Now the only thing I need to do to solve this equation is to get rid of the squared with the h. Now to do that, I have to do the inverse of squaring, which is going to be square root. So I take the square root of both sides. When I take the square root of the left side, the square and the square root will undo each other, and I'm left with just an h over here. On the right side, I take the square root of 36. Now, the one main thing to take into account is that when you take the square root of a number, we technically could have a positive or a negative number. Right, so the square root of 36 could be a positive 6, so positive 6, or it could be a negative 6. All right, so we have two answers, and we can write that quickly with this plus or minus sign. This means a positive 6 or a negative 6. All right, so if you don't like that sign, you could just write it out as two separate equations, where we have h equals a positive square root of 36, and h is a negative square root of 36. You could write it out like that, or just write it as plus or minus the square root of 36. Either way, we have two answers. This would be a positive 6. This would be a negative 6. So we have two answers, 6 or negative 6. And again, we could write that with a plus or minus sign, which means we have a positive 6 or a negative 6. So the key for solving any sort of equation with exponents is I want to get rid of the exponent by doing the inverse operation, which the inverse of squaring something is taking the square root. So whenever you see a square, I can get rid of it by taking the square root of both sides. So let's take a look at example 2. Here we have x minus 3 squared equals 100. So again, we want to get rid of the square. All right, so what we can do is we can take the square root of both sides. When I do that on the left side, the square and the square root will undo each other. I'm left with an x minus 3. On the right side, don't forget we have two possibilities. We have a positive square root of 100 or a negative square root of 100. So I can write it like this, or if you prefer, you could write it out as two separate equations. X minus 3 equals a positive square root of 100, or x minus 3 equals a negative square root of 100. So whichever you prefer, you can do that as long as you make sure that you have two answers. So let's do it with the two separate equations first. All right, the square root of 100 is 10, because 10 squared is 100. So I have x minus 3 equals positive 10, or x minus 3 equals negative 10. So to solve, I can add 3 to both sides. Here we have x equals 13. The other side, add 3 to both sides. We have x equals negative 7. So we have two solutions, 13 or negative 7. If we kept it like this, as one statement, we can write this as x minus 3 equals plus or minus the square root of 100 is 10. All right, and it's actually probably helpful no matter what when you have this to immediately write this as two different equations, because if you don't, you might make the mistake of finding one answer and then just automatically making it negative, which would not give you the correct second answer. Right? If you solve the 1, you might think, oh, x is 13, so make one positive, one negative, positive 13, negative 13, but that's not the correct second answer, because your second answer is actually negative 7. So it's good, probably in these situations, to write this out as two separate equations like you see right here. And then at the end, we can always double check our answer by plugging in these numbers back into the equation. So if I plug a 13 in, we'd have 13 minus 3, which is 10, and 10 squared is 100. So that one works. Plug a negative 7 in, negative 7 minus 3 is negative 10. You square negative 10 to get positive 100 as well. So we've checked our answer, and both of these would work. At this point, we are going to transition into a little more difficult of problems. Now, before we get to the more difficult problems, we first need to understand a quick concept. And that concept is the idea of a perfect square. Now, when we say a perfect square, what we mean is something like x squared, or x minus 3 squared, or 2x plus 1 squared. So something squared like this. And when solving, so if you have an equation and you're trying to solve it, what you want to do is you want to isolate these perfect squares on one side of the equation. So you want to isolate whatever the perfect square is. And then at that point, you can take the square root of both sides. So for example, here we have 6y squared equals 54. All right, we see the y squared, that is my perfect square. The 6 over here is kind of messing me up a little bit. So I need to move the 6 over first to isolate this y squared. So let's bring the 6 over first. We do that by dividing. So we divide both sides by 6. We now have y squared equals 9. So now that we've isolated, we can now at this point take the square root of both sides. When I take the square root of the left side, the square and the square root will cancel. I'm left with just a y over here. On the right side, I take the square root of 9. Just don't forget it is a plus or minus square root of 9, which means that y could be a positive 3 or it could be a negative 3. So you could write it like this if you want, or write it out as two separate answers where y equals 3 or y equals negative 3. So going back to this process though of isolating, so maybe another way you can think of this is when you're solving, remember you want to do reverse order of operations. So we see here 6 times y squared, that's multiplication. We see y squared, that is my exponent. So when I solve, I go in reverse order of operations, which means I'd want to get rid of the multiplication first before I do the exponent. So either way, what I need to do is get rid of everything that is with the perfect square. So here is another example. We have h squared plus 3 equals 28. So the two ways to think of this is we do reverse order of operations. So this is the first way. And to do that, we see addition. So that's going to be the plus 3. Then we see h squared, which is an exponent. So I want to get rid of the addition first. And we do that by subtracting 3 over. Now we have h squared equals 25. The other way to think of this is we're trying to isolate this perfect square. So we're trying to get the h squared by itself. And we've done that. All right, h squared is 25. Now at this point, I can get rid of the square by doing the inverse of squaring, which is square root. So I square root both sides, which will get the square to cancel out. That gives me an h over here. And on the right side, don't forget I have a plus or minus square root of 25. So a positive square root of 25 is a positive 5, and a negative square root of 25 is going to be a negative 5. So my answer is h equals a positive or negative 5. So I can write it like that with the plus or minus sign, or as two answers where h is 5 or h is negative 5. And at the end, I can always double check by plugging my numbers back in to see if we get a true statement. And when we do, we find that in this case, we will have the correct answers. Here is another example. We have 4 times x minus 3 squared equals 36. So again, we want to isolate this perfect square. All right, I can think of this if I wanted to as reverse order of operations. All right, we see 4 being multiplied, we see an exponent, and we see stuff in parentheses. So begin with getting rid of the multiplication first, and that will isolate this for me. So when I do that, I get rid of the 4 by dividing. So I divide both sides by 4. This would give me x minus 3 squared, and then 36 divided by 4 is 9. So multiplication is done. Now we have the exponent. So at this point, I can get rid of the perfect square by taking the square root of both sides. On the left side, the square and the square root undo each other. I'm left with x minus 3. On the right side, I have the square root of 9, but don't forget it is a plus or minus square root of 9. So what I have is x minus 3 equals a positive 3, that's the square root of 9, or x minus 3 equals a negative 3. Now because I need to solve, it's probably helpful to write this as two separate equations, where for both of these, I solve by adding 3. So I add 3 to both sides. I now have x equals 6, add 3 over here, and x would equal 0. So my solutions are x equals 6 or x equals 0. And I can double check by plugging these numbers back in, and we would find that we would have the correct solution. One more example. Here we have a lot going on. We have 3 times 2x minus 1 squared minus 4 equals negative 13. Now, when I solve equations, I want to do reverse order of operations. So we see here the minus 4, that is subtraction. The 3 in the front, that's multiplication, 3 times the parentheses. We see parentheses, the 2x minus 1, and we see the exponent, so the square. Alright, so when I solve, I work in reverse. So let's get rid of this minus 4 first. To do that, I want to add 4 to both sides. We now have 3 times 2x minus 1 squared equals negative 13 plus 4 is negative 9. Alright, now from here, I want to get rid of multiplication. So subtraction is done, now the multiplication. So let's get rid of this 3 that's being multiplied by doing the opposite, which is divide. So I now have 2x minus 1 squared equals negative 3. Alright, so multiplication is done. Next we have the exponent. So to get rid of the exponent, I can do the inverse, or the opposite of squaring, which is square root. So I take the square root of both sides. This left side, we're left with a 2x minus 1. The left side, we have a plus or minus square root of negative 3. Now before I go further, take a look at this radical, the square root of negative 3. Now the square root of a negative number, this is going to be not real or imaginary. Alright, so therefore, this will not work out, and we say our answer is imaginary. Alright, so in your future studies of math, you will talk more about imaginary numbers, but for now, we're just going to leave it like this, as an imaginary answer. And that concludes our lesson for today. We will see you next time.